Look at a little history of the periodic table. All right, so early attempts to organize the elements, it kind of started in the 1700s. Only a few elements had been identified. Things like copper and lead had been around forever. The fancy way of saying forever is ancient times. So they didn't really need to do any massive scientific process to identify these elements. It was just kind of known. The first attempt at organizing the elements was to organize them by chemical properties. Kind of makes sense. And it was based on how they reacted with other elements. Johann Dobener from Germany in 1829 did this. He used something called triads to organize them. So he was grouping elements in groups of three, tri being three. And he based this on the triads. He based the triads on chemical and physical properties. He also observed that the atomic mass of the three elements within a triad formed a pattern. So this was a good start. However, there was some limitations. One of those limitations was that not all of the known elements could be organized this way. They didn't fit nicely into a triad. So in 1839, or in the mid-1800s, I guess, John Newlands arranged the elements in increasing order of atomic mass. And he noticed that every eighth element had similar properties. So he called this the law of octaves. Octaves meaning 8. Limitations of this method was that some elements were still missing. And the law did not hold true for elements heavier than calcium. So up until calcium, this octave thing was on point. However, anything heavier than calcium, this rule fell apart. So then enter the Russians. In 1869, Mendeleev organized the periodic table by increasing atomic mass. Some chemical behaviors he noticed repeated at regular intervals, and he called this periodic. The atomic mass increases from the top to the bottom of the column. So the lightest element is at the top of a column, while the heaviest would be at the bottom then. Elements in the same row exhibit similar chemical properties, and the newfangled thing that he did was that he left blanks for undiscovered elements. Because he thought that those elements had to be out there. He was kind of a forward thinker and just thought, well, they just haven't been discovered yet, but they're there. So as we advance, the Brits want to get their hands on this. So Henry Moseley in 1913, he examined the X-ray spectra of elements, and this result led to the definition of atomic numbers. So now he arranged the periodic table according to atomic number. And this we call the periodic law. When elements are arranged in order of increasing atomic number, there is a periodic repetition of their chemical and physical properties. This law has resulted in the chemical or the periodic table as we know it today. Each new horizontal row corresponds to the start of a new principal energy level. This should be reviewed from last unit. So the modern periodic table is a way of arranging the elements in order of their atomic numbers so that elements with similar properties appear in the same vertical column or group. Each square then shows the chemical symbol and name, the atomic number, and the average atomic mass. So when we're looking at the horizontal rows, these are called periods, and there are 18 periods on the periodic table. They begin on the left, and as you move to the right, they typically will increase in atomic mass. Each starts a new principal energy level. Periods 6 and 7 have 32 elements in it because the two bottom rows are separated out, so those would also be counted in the 6th and 7th rows. 7 and 18. Good catch. So then the group is the vertical column. There are 18 of these groups, The traditional naming system called them A's and B's, but that system kind of got confusing. So we have a second system that uses the numbers 1 through 18 now. So most periodic tables number their columns with 1, 2, 3, 4, 5, 6, 7, all the way up to 18. But if you have an older periodic table, you might see some A's and B's thrown in there. Yeah, that one. Kind of. That one's got other stuff on it that those A's and B's correspond to. So just some groups within the periodic table. Your metals are elements that are good conductors of heat and electricity. They're malleable, they're ductile, they have luster, so that means they're shiny, and they are solid at room temperature. Metals are then found to the left of that diagonal. Nonmetals is an element that is not a good conductor. Usually they exist in all 3 states of matter at room temperature. However, the most common would be gases, the second most common would be liquids, and it's uncommon for nonmetals to be solid at room temperature. Metalloids then are elements that have properties that are in between or intermediate of metals and nonmetals. So the metalloids are on this diagonal, and then the nonmetals are in the green to the right of that diagonal. Aluminum is considered to be a metal because it has more characteristics of a metal than a nonmetal. So that is one of those that could have been on that diagonal, but it is not. And you'll notice that it is blue up here, indicating that it is a metal.